Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 378 Palindrome Rearrangement queries. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this video is going to be very long just because the live portion is very long. Don't worry, the explanation is much shorter. If you are curious about the live portion, you can definitely watch it. That's why I included it. But like I said, the explanation is much shorter. So let's first of all let's convert this problem a little bit. This problem, it's you can see that for each query you have this A, B, C, D thing, but A and B only operates on the left side, and C and D only operates on the right side. And of course, in a palindrome, all you care about is the left-right side, right? In a way. So yeah. So the way that I would think about it is that, for example, if you have, let's just say you have this string, right? The way that I would think about it is just converting it by chopping it in half, and of course actually rewording it a little bit. So then now you have two strings, and then now the equivalent problem is you could swap some portion of the top and some portion of the bottom, where you can change any order in any way. And I'm gonna just bang on the keyboard a little bit so that you could kind of just a little bit different visualization for a second, and then try, and of course the Leetcode, and see if that you can make them the same word, right? So that's basically the idea. I'm going to start, and you can fast forward this a little bit. This is just me doing a retrospective of me during the contest. This is how I try to learn, both on just the algo and the implementation, but also just like strategy and stuff as well. If you don't find it interesting, you can fast forward or watch it on 2x or whatever, right? But yeah, but basically, I think this is one of those problems that, to be honest, I definitely should have gone. I didn't get this during the contest. I had a lot of time, I had 80 minutes to solve this. I really should have gotten this, but some days you just, some days you're just a little bit off, and that happens. But also, to be honest, I think I got a little bit thrown off, a little bit tilted on both Q3. I was a little bit slow, but another thing is that Q where the number of queries, Q is the number of queries, is 10 to the 5th. I had some algos that's like 26 times, or alphabet 8 alpha 26 is the number of lowercase English characters, and that times 10 to the 5th is of course 2.6 million. And of course in on Leetcode, that unless you're doing way cheap things, it's going to be kind of sketch, and that's what I thought a little bit as well. And yeah, and to be honest, and we'll go over some numbers a little bit later on, because for that I want to show you some code as an example. But I think it just gets into my head a little bit in that in Leetcode at that point, it's just one of a few things. One is that get lucky with mind reading, or just RNG and get lucky, right? And what I mean by that is that, for example, the code that I'm going to show you, it actually runs in about 4 seconds, 5 seconds. There is an optimization that I will also show you that gets it down to about 2 seconds in Python. Great, right? But of course, that is a lot of mind reading, because for a lot, and if you haven't done a lot of Leetcode problems, especially during the contest, especially during Q4, it is just, like they could, I don't know how many test cases there are for this one. I didn't actually check, but they can easily throw double the amount of problems or the number of inputs. And because basically the time limit, the way that they implement time limited on Leetcode is the sum of execution time, meaning that for all the inputs, it just sums it up. So that means that it almost doesn't even matter, because they can just, like, even if your code works for the max case, if you have the max case and it works, it doesn't mean that it'll pass Leetcode, because they can have just twice the amount of input, right? And that means that you have to do optimization sometimes, and a lot of times on Leetcode for contest, you don't know if those optimizations will be good enough, because let's say, like I said, for example, I have a algo that works in 5 seconds. if they double the number of inputs, that'll take 10 seconds. And maybe that's too slow. And I have an optimization that cut it down from 5 seconds to 2 seconds. Or if you do the math, it may cut it down from 10 seconds to 4 seconds. But that's very binary, right? At 10 seconds, I know that, or it only tells me that it is too slow. So it doesn't tell me that it's 10 seconds. So I don't know that, like if I was doing another equivalent thing of like with my code takes 30 seconds and it cuts it down to, what is the math? 40%. So like it cuts it down from 30 seconds to 12 seconds. It's still time limited and it's still not enough, but cutting it down from 10 seconds to 4 seconds is enough. And of course, these optimizations are not like an O of N factor or Q factor. It is just like, changing a few simple things. So this is what I mean by in the meta, there's a lot of mind reading or just luck or whatever. And sometimes it gets into my mind sometimes. And I do, as a result, and I don't know if this is the best strategy, to be honest, but as a result, sometimes I do prematurely optimize my Python code. But those premature optimizations are not free. They allow you to submit at a like it allows the submission to be fast, or your submission time to be faster, or submission time is going to be longer because you're writing things in a less Pythonic intuitive way. But your code would run a little bit faster, but even then you don't know if it's fast enough, right? But you have to make that trade-off because like at some point it's just too much mind reading, too much guessing, too much thinking about like, is this going to work? And it's just a lot of like not working on the hard part of the problem, which is, or not even the hard part, but the interesting part of the problem, which is solving the problem, right? Like if you're doing a contest, you're not trying to ask if someone knows how to do certain optimization. You just ask them if you know how to give, solve the interesting part given reasonable optimizations, right? Anyway, that's my rant, and that's why I didn't solve it. That's my excuse, if you want to call it that. But to be honest, like I just really, I think I was trying to like really optimize out like, so my solution is going to be Q times alpha, where and also N times alpha, where alpha is the size of the alphabet. And I really was trying to optimize out the alpha part so that it'll be like maybe Q log N or something would be a little bit faster, maybe not in this case, but like stuff like that. So I was just trying to really hard to optimize it out. So when people talk about Leetcode Python inconsistency, or at least that's when I say people, I guess I mean me really. When I talk about Python Leetcode inconsistencies, sure, there are problems where the cost is obvious, right? Meaning that you get a TLE, you get a time limit exceeded, and you're like, oh man, I have to see if I can, that, and then you submit it with a minor optimization and you get it right, and you get a 5-minute penalty for no reason. So that is a very real cost, obviously, and you could see it. But it also comes in these meta mind games, almost like, where like you don't even get the right answer because you just psych yourself out of the answer. I don't know. I don't know what the right answer is. But I know what the right answer is that Leetcode needs to get rid of, needs to get rid of per test case tests. But without doing that, I don't know what the right answer is for me to, like, the right strategy is. I don't know. Like, should I prematurely optimize? Should I only optimize after getting TLE? Should I just use C++, which I always forget because, I don't know, I'm just in a Pythonic mood. So, I don't know, right? I don't know. But anyway, let's get back to the problem. Sorry, friends, that, wow, did I really spend time on this problem? But, yeah. Anyway, so it turns out that this thing isn't that complicated because you only have one range on the top and one range on the bottom. So it turns out, I mean, the implementation is very tricky, don't get me wrong. So don't mistake this for an easy problem, but it's not a complicated to explain problem. and it is, and of course you have to convert the ideas into code and implementation. So you have some basis as well. But that said, yeah, I mean, we'll go over all those things, so no worries. Don't worry, be happy. But yeah, but the core idea is that the core idea is brute force. But not brute force, but just case analysis, exhaustive case analysis, right? So we'll go over, it turns out that there are already only 3 distinct cases, and maybe 6 if you want to count some like symmetric version of them. And in those cases, you can just kind of go through all of them, and we'll go for all the explanations, so no worries. Yeah. But basically, okay, let's start from the beginning, right? Let's pretend that all the characters are whatever. So let's say that you have 2 spans, one on top, one on the bottom, or one on the left, one on the right, if you don't prefer that. But this is how I visualize it, right? In this case, there are no overlaps, right? So I'm just going to call it no overlaps because there are no overlaps. And what does this mean, right? So this is probably the simplest case to understand. It just means that, well, now all that means is that all the characters here has to be like the count of all the characters here has to be all the same here, meaning that you can rearrange this into this, right? And you can rearrange this into this if, maybe I'll use this slightly bigger for now, zoom in. Yeah, and you could use this into this if they contain the same characters, meaning that, you know, the same number of A's, the same number of B's, the same number of D's, and so forth, right? And then you could just match them together. And then, of course, for the other span, it is the same thing, right? You have same number of A's, same number of B's, same number of D's, and the same here as well. So, and then, of course, so that's that's one way. And then, of course, the stuff that you don't have that you cannot swap, they also all have to be exactly the same. Not just the same characters, but exactly the same in the same order, right? So that's basically the idea, is that you break this down to to those components, right? So that means that you have to have, yeah, I mean, I won't label it, but you get the idea. And then now there is one overlap, maybe? I don't know if this is quite the right way to say it, but I'll show you in a sec. It just means that there is an overlap. And maybe the best way to show what I mean by this versus the third case is that it is what's it, inside. I think I just called it inside. And what I mean by inside is just that one segment is inside each other. So you have something like this, right? So then one is totally inside each other. And yeah, and we'll go over the one overlap case. I guess there can only be one overlap, but I just distinct it from inside. But yeah, you can call it whatever you like, but these are the 3 cases, right? And of course, like I said, 6 if you want to count the symmetric version, which we'll go over. I mean, you just flip them, but you can think about it. But yeah, basically the overlap case means that, well, everything that's outside the overlap, right? So in this case, it'll be the first character and the last 2. They have to be exactly the same. And then now it just means that the things that are fixed, meaning the non-overlap portion of the bottom, this has to match with this. And of course, this has to match with this, right? Pretty straightforward, basically because you don't have freedom here. Oh, sorry, I lied. Sorry, I'm wrong. So these are the fixed characters, and you get these fixed characters from any of the span, because you can move this E to here, for example. So yeah, so that's basically the idea, and the same for here, because you know you have this RAW, but you can take that RAW from any of these things. And if everything else is so, I think this is the part that I struggle with during the contest, is that you're moving stuff around so that, like, for example, if there's a, let's just add a random X here and a random X here. And my thought was that, and I couldn't figure this out during the contest, or I just didn't really follow it through the entire way during the contest, is that the only way to solve this is get this X in here and get this X into here. So I was kind of playing around this idea during the contest, but it turns out it's not necessary, because if this, it's almost like a pigeonhole thing. If you match these and you match these, then everything else will be in here, and by definition, they will match. You can match them, right? So that's basically the idea, assuming that this match and these two match. And of course, I think I skipped one where all the characters in the first string has to match all the characters in the second string in some order, because obviously if you just have different characters, then they'll never match no matter what, right? And that's basically the idea, and this case kind of confused me too much that I didn't solve it as a result. And when I did, I had, like, veered off by ones as a result. And then the inside case is actually more straightforward, right? Basically, you have the before and after, and then now you have this prefix BBC, for example, has to exist within the span, and this thing also exists within the span. And that's pretty much it. Those are the three cases and the symmetric one, so that's 6. And we'll talk about how to implement them in the code. But that's basically the core idea. Like I said, not super complicated. It doesn't make it easy, and I can't even say it's easy because I didn't solve it, right? But or at least during the contest, obviously I solved it afterwards. But yeah, and we'll go over why one reason why I didn't kind of, like, I could have followed it a little bit, but I was trying to figure out a much more optimized route, just because, like I said, I really worried about TLE. I don't know why I did, but in the moment, I guess it is what it is. But yeah, okay, let's go over the code. Let me make it smaller so you can actually see some code. But yeah, basically, okay, yeah. I just want to make sure that this is the code that I want. But yeah, basically, this is just saying, let me rewrite this slightly so it is more clear. Like I said, I convert this to the left, to right, by splitting the string into 2. I flipped right because there's a palindrome, so they just have to match. And the first thing I do is just make sure that all the characters match. Otherwise, everything's going to return false. So that's what this looks like. And then I just have a new M, and this is to get the prefix. So this is the core idea of the problem. It's just to get prefix sum, and basically, this is I do a prefix sum for each of the 26 characters, and that's basically how this works. Yeah, I don't think I'm going to go over prefix sum for this problem. Definitely, there are a lot of prefix sum problems on Leetcode. Definitely go over them. I go over them in a lot of videos, but I'm already 20 minutes in. I don't want to spend even more time here. But the quick idea is that it allows you in over one time to get the number of each character within a span, right? So this allows us to set it up, and we'll go over it a little bit more when we on the queries, but this is how we set it up. It's just that when we see the letter X, we add a space there, and then we just kind of sum it up in a prefix sum kind of way. And then I also have a delta array, and this basically just allows us to kind of calc, tells us where we have an unmatched, an incorrect, and unmatched character, right, for the index. So that's basically the idea here. Yeah. And this count is a helper function. For a given prefix, return an array of 26 characters that shows the count of that character from left to right inclusive. That's basically the idea. I don't know if the English part is any better, but yeah. Then this is of course just very core prefix sum thing. So for each of the 26 characters, we just look at the right minus the left. Not going to go over prefix sum in this one, but that's basically the idea. And this is just the exact match. So then the exact match is, you know, we have string X and string Y. We'll show the usage later. And it's just, you know, you count the left, you count the Y. You count the number in the X string and the Y string, and then you just return the thing. Of course, and this is the prefix, and this is not actually exact match. This is just exact match on the number of each characters, right? So another way of saying it is that yeah, you can rearrange X into Y by swapping, well, X of left to the right into Y of something like that, right? And then now extra is just, it counts match of extra. So this is basically used for this case of like you have one so Y is going to be in exact, so everything in Y has to be somewhere in X, and that's basically what this extra count means. And yeah, and basically you get the X count, you get the Y count, and then for each of the 26 characters, it just makes sure that you have enough in the extra one that can fit into Y. So otherwise we return false, otherwise we return true. And then inclusive just matching, it just basically counts the number of incorrect indexes from left to right inclusive. That's basically the way to do it. Yeah, and then check. Wow, I really have a lot of helpers. But yeah, but check just allow us to, you know, given the prefix L and the span A, B of L, the prefix right and the span C, D of what? Check if it's true. Check if it can be, if the query is good. And that's basically, you know, we'll go with this part real quick because that's at the top, right? So basically for A, B, C, and D that they give you, I re-index the C and the D because now, you know, we're doing the reflection and the second string and stuff like that. And this is basically the way to reflect it. And I just check it for this, for prefix L, prefix R, A, B, C, D. And the reason why this is so wordy is we'll go over it. But yeah, and now I go for every possible case. And it turns out, like I said, there should be 6 distinct cases, right? 6 cases, not all of them. Like, depending on how you want to count symmetry. For example, now I just have A is less than or greater than or equal to B, less than C, right? So basically you have this case, which is, I guess, this case. Oh, no. Oh yeah, no overlap. So it is this case. And then in this case, it just means that you have to match the right into the left of the span A and B, and then the left into the right span of C and D. I think technically, I guess the L and R in this one order doesn't matter, but it's just easier to be consistent. And then also and this is the left, the right, and the middle. And kind of just to kind of bring you, I'm gonna just, you know, let me paste this in here so that you could kind of have visualization as we do it. So that's basically the idea, right? So you have these things. And no overlap just means that this part is matching this part. This part is matching this part. This part is matching the prefix. This part is matching the stuff in the middle between the 2 segments. and this part just is the suffix, right? And that's basically the idea. And then now you have the other thing, which is D is less than A, which is basically the swap, right? So it's like this one's here and this one's here. And the way that I do it, now you understand why. It's just that I swap L and R, and by swapping it, I also swap C and D and A and B, and I just do another check. So this basically just, we know that if this is the case, then this will run this code. So it's just, you know, so that we have fewer ways to make mistakes. And then now you have a regular overlap, which I will also copy and paste it down here, right? So yeah, and this is basically what we went over, right? So so you have this part, the extra part, and the way that this API is a little bit messy, but it just goes from A to B on the left, and then A to C minus 1 on the right, so the smaller case. So this part is saying that from A to the B, which did I mess up the overlap? Oh, no. Yeah. Whoops, sorry. The overlap is C to B. So from A to C, or C minus 1 in this case, from A to C minus 1, we have to match everything exactly. And then this second one is the same, but on the other side. So you have from B plus 1 to D, you have to match exactly. And then, as we said, you have to care about the prefix and then the suffix. And that's pretty much it. And then this is the other overlap, or the symmetric version of the overlap. So let's say you have something like this, and of course then we just kind of flip them by, like I said, converting the right? Maybe I could have had a helper function for the flip as well, but we'll talk about some stuff later. And then the inside case is the last case, and it is what it sounds like. Yeah, and basically this is inside, and it just means that, well, yeah, I actually used a different example of this matches anything here and this matches anything in here. Are they equivalent? That's what I'm trying to think. I guess they should be. I guess actually, technically, you don't even need any of this, right? I'm gonna double check this, but yeah, there are a couple of ways to write this. But actually, now that I think about it, you don't even need to match, because I think if this is equal to this, then by sorry, if this is equal, the prefix is correct and the suffix is correct, that means that everything inside is also correct based off the fact that we already did, where is it? Oh, we already did this match here. So therefore, I think this is actually good enough. But I didn't think about that during the contest. Because actually, I'm going to just give it a quick submit. See if it's still right. Should be a little bit faster. So yeah, don't know about the running time. So let me check the running time real quick. I guess it doesn't show up here because this is after the contest now. Where does it show up? No, well, fine. So yeah, so you could see that it saves us some time, but you know. But yeah, but it turns out that's even cleaner. So yeah, we just have to care about these two. And of course, there are other ways to write it. So even if you do the middle, it's fine. It's just a little bit slower. And of course, the symmetric version, again, you just flip it. And then I have this thing here just so that I know that it hits here, at least during testing, because, well, the cases that we talked about should have been all the cases. But just in case that I was like, maybe mistype something or whatever. So this should never happen. And that's pretty much it. Yeah. Everything seems pretty straightforward. Match. I mean, so yeah, let's go over the complexity real quick. Obviously, there's O of Q queries, so each query will call one check, and one check requires at most 2 matches or 2 extras and a couple of goods, right? But you know, this is O of alpha, this is O of 1, where's match, and this is O of alpha as well, right? Where alpha is O of 26. So you can say that most of the time, I guess this is O of 1 if the one is inside the other, but yeah, and actually even in this, I think in this case you could throw away one of these. Yeah, and maybe even if you want to do a premature optimization, you do the expensive stuff at the end. Maybe that's what I should have done. But yeah, but these are the but that's the complexity. That's the idea. We'll go over. So this is O of n times alpha, or n times alpha plus q times alpha, however you want to say it, because for each one we do pre-process this into O of n times q, sorry, O of n times alpha. Sorry, mixing things up. So basically the total time complexity is going to be O of n plus q times alpha, where alpha again is the size of the alphabet, and then the space complexity is also O of n times alpha plus q, because q is just the answer, right? And that's pretty much it. So the idea is not that hard per se, but of course you have to be really, like, I don't know, alert and difficult and stuff like this. Yeah, so that's basically all I have for this one. I am going to go over a little bit more about, like, my thoughts about this problem and just show you some numbers about optimization. But yeah, actually, let me have this. Oh yeah, this is already out. So basically, about optimization, and that's why I was looking for a cleaner solution, is for this reason, right? Is because like I said, the code runs in 5 seconds, and it's just a lot of uncertainty around that. And maybe I'm not gonna lie, some of it is my fault still, in that I prematurely did not go for it. And maybe some of it is just in a retrospective way, I just don't have the energy, right? Because on days that I have energy, I will grind it out. And today, maybe I just didn't, like, almost in a lazy kind of way, I was trying to find something easier when there's no easier solution, right? Maybe, like, I was looking for something that I don't have to grind, but now this is a grinding problem, right? So yeah, but the way that I was saying is that, as you can see, the range of all these accepts, there are a lot of different variations, and it turns out a lot of them are kind of silly. For example, well, like I said, like, you know, you saw me kind of removed one thing, and and that's only a O of alpha, you know, like, it's not a very expensive query, right? Just O of alpha times a good amount of queries, like 26 times n or something, or 26 times q or something like this, and yet that alone saved like 8% or something like this of the running time. But it turns out, you know, this good function, right? For example, let me put it here. Good function just does this, and it turns out if I just convert a couple of these, I forget which one I did, but yeah, like I optimized it to 4 seconds. I don't even remember how, but I converted it to 2 seconds, 2.5 seconds, by converting the inside case, which I guess is the one that I was looking at, into delta, right? Into basically what I call inline. I think maybe no, yeah. But I just kind of converted to inline if statement versus calling the function, and that saves a whole 2 seconds, which is ridiculous, right? And what I mean by that is that I see this, I can convert this to delta of what was it, a minus 1. So I convert this to delta a minus 1 plus 1 minus delta of 0 is equal to 0. So that's what I mean by. That's what I mean by inlining it, so that now I save a function call, a method call in Python, which is not super cheap. I save this, and this saves like a second, which is like a ridiculous optimization, right? And like I said, there's no way to know before you run it, or you submit it rather, to know whether this optimization is going to be enough, or whether not having this optimization would time out, right? Like this could easily time out, and I would know that I would never guess. Maybe not never, because I mean, I guessed it now, but it would take me a lot of effort or convincing to convince that, like, hey, if I just convert this into using the arrays directly instead of calling a function, I know that is cheaper, but I don't know how much cheaper, and that is going to be good enough, which is a ridiculous thing. And yeah, and there are other optimizations that maybe I could do. Like, for example, I probably should have done this, because this is way cheaper than the other one. It's like not that much cheaper, but just slightly cheaper. But I'm gonna, just for science, curious what that gives us. So yeah, run it real quick. So the code before, internal error. But yeah, see, just changing the order of operation of some of these things already saves it also another 2.5 seconds, right? Again, no way for me to know. So, and I'm not, and this time, like, I'm not shifting all the blame. I'm just shifting, I'm just explaining my mindset during the thing of, like, just the uncertainty, the mind games, the meta, and the tiltness or whatever of everything, of me just trying to figure out how many things I need to do, and whether, like, like I could imagine in another universe, maybe there's 4 times the number of inputs, and this 5 seconds is now 20 seconds, and it, like, even if I do all these optimizations, it's not good enough, and the reason why this isn't good enough is because there's a easier solution, or not easier, but a cleaner solution where the complexity is lower, right? Maybe there's an O of Q log n solution or something like this. Maybe not log n, but and for me, during the contest, it's hard for me to kind of figure out that I need something faster on like how much fast I need to do, right? And I think that's what contributed to me not solving this. But apparently, like, even if I just switch the order of, like, the expensive stuff at the end, I would save some time, which is not really, like, intuitive, right? Like I said earlier in the video, I could have tested worst case, and it would pass for sure, because I mean it passed now even with all the cases, but it doesn't guarantee me that it'll work for the input. So I don't know. Maybe I kind of mind game myself out of solving this problem, but still, it's not a mind game that it's not like a pure mind game, right? Like, it's not like me being silly to myself for no reason. It's a mind game from too many years of experience due to Leetcode still refusing, or maybe cost too much. I don't know, right? Like, maybe it's a good reason, but either way, it was a good reason or not. It is a sad reason for Larry to kind of contribute this, and that's what I mean by sometimes even when you don't, even when I quote unquote don't solve the problem, it still is because of this history of inconsistency of Python and Leetcode and Q4 and one-time error, right? Or like one execution time total. So, but that's all I have for this one. That's all I have for today. Wow, this is a 40-minute explanation. But yeah, there's a 2-hour thing coming up. It's the live portion. You don't have to watch it, but if you do, I don't know, have fun. That's all I have for this one. Let me know what you think, and you can watch me solve it live eventually during the contest. Now, reverse the order. Well, not going to be top 10, I'll tell you that much. Alright, let's see. What am I doing anyway? What's so fast? But 2 long answers is too silly on that problem. Especially since I knew how to do it. Focus. Okay. Even length. Okay. That's very unfortunate. I think I would have had a very good score without it. Okay, focus line. Okay. What does a palindrome mean? Oh, this is only on the left half and right half. Okay, so that's actually pretty important. So then that means that, okay, that's actually not that bad then, maybe. No one's on it yet though. 20, so many submissions, so I have to worry a little bit. Yeah, whatever. I don't know which one's cleaner, either way. Then now let's say it is in theory possible. And what does that mean? It's just like a... I don't get why this is hard though. People should have gotten it by now. What's that now is just... What does it mean to be swap? Okay, so now we have a requirement set. What do these overlaps mean? Wow, a lot of people got actually. Oh, well, I would have gotten it faster if I didn't. But that, I mean, that's actually pretty bad. Look at all the I didn't have 3 mistakes, it would have been faster. Or maybe just do them both at the same time. Alright, focus lag. Alright, what does this mean? That means that if one of the two is in it, it's probably okay. Is that true? So all these numbers have to be in the change set. What does that mean? This is not a good day to have 2 wrong answers because maybe people won't get this one. Does that mean that you have to put I? You have a long number. Okay, I think I got it. You only need half, so I'm trying to. It's hard to believe that I'll be the first person to solve this. That's why I'm also like taking my time a little bit. I think this is a little bit off, but maybe that's fine. Because I think I only need half of this. But the other thing, do I need to pre-process the queries in any way? No, this is the same as oh, this is actually a little bit annoying. How do I do this? Because AP is not always okay, I mean that part is right, but how do you overlap? Oh well. Why is that? This is so silly. I need better debugging templates, maybe. Oh, because I am dumb. I don't think this is right, but I'll take 5 minutes penalty. Actually, let me just do one more. So one that is in between each other. Should be open. Alright, well, let's give it a spin. Did a little bit of due diligence, probably still wrong, but at least I should be able to get an attempt. Why is this wrong? Why is this force? If you could swap everything. Maybe that's why no one's got it right, which is actually pretty sad because I got such a slow Q3. Well, the Q3 speed is fine, but okay. Gotta save it down somewhere. That's actually interesting. I didn't think. I thought that I could just do it this way. But why not? A is fine. I see, because there's no way for the W to get there. I was mistaken about adding the overlaps. Okay. Huh. Maybe it's a union find problem then. Gotta stop doing that. Basically, we're trying to get the W into the here, but you can't, even though I thought that. Yeah, I guess I cannot combine it the way that I did with the left and the right. Still no one. Am I able to get this at all? I have some ideas. I think I have to prove them. Okay, so then that means, what do I mean? For each character, you have a map of left and right, but you can't combine them, so it's just individual. I mean, that's tricky because you can kind of merge in the middle. If you have two of them, you can merge in the middle. Well, you could actually merge from the middle, from the left and the right anyway. Well, yeah, the problem isn't merging in the middle. It's that you have, this has to move and this has to move. Well, one of them has to move. So basically, what am I trying to say? So let's say you have a W. I have to think about the constraints. Let's take a look at the constraints. Okay, I mean, okay, let's rewrite this. This palindrome thing is too weird. So let's say you have, oops, this, and then now you're rewriting it like this. Okay, so now you have two strings and you have a query to see whether okay, in this light you have 0 to 5 and 10 to 14, which is maybe here. So you have this one and you have this one. If I had this, is this okay? Yes. We have to be able to do an O of 1 or O of log n anyway, or O of alpha maybe. 3 people got it right, so so it is possible. Okay. So, but I thought that you can merge them. I guess the not being able to merge them is kind of a tricky part. That's the thing, right? Like, it's not even just like a prefix thing. Because you can't even do them independently. Because it is possible that if you did this, well, what if you did this? Right? Like, this is the biggest thing if we have, but here it is not. Even though here the A is able to get to the A, so we have to kind of merge the maps somehow. 10 to the 25th times 26 is a little bit tight, but how do you determine? Like, this A is able to get to this A. Okay, so the first W have to match the first of each character has to match the first of each character, and so does the last. What does that mean? That means that you have all these ranges of, like, you have 26 ranges. 52 maybe, I don't know. So it creates constraints. basically I want to match. Why am I so bad at this? Okay. Is that the right one? What is it called? I always forget. ASCII lower key. I don't know if this makes any sense, to be honest. It's just an idea, but I think that makes not solving Q3 faster or in a less error-prone way. Doubly sad. At 45 minutes, I don't even know if this is good enough, to be honest, like I said. This is wrong. I mean, this part is right, but and then basically And now I don't even know if it's fast enough. But again, how do you ensure that these things, so to cover 6 and 9, which one is 6 and 9? One and 3, okay. So there's the 0 and 6, but also 1 and 7 somewhere. 1 and 7. How do you assure that 1 and 7 is good? Seven has to be here. We're going to 1. This one is true. It has to do 0 and 1. How would I check that this constraint is good? That's not enough, is it? No, because you can have something like, because even if they overlap, it doesn't mean that they have, you just put in that overlap. You have to put multiple things in that overlap, maybe, and that may not be good enough. There must be a similar thing for it. I can't figure it out. Because this isn't good enough. Because you can have something like, or maybe just something like this. Because you have two overlaps. That still doesn't mean you could do it, even though you could greedily choose one of them to do it. So how? What is the recurrence I'm trying to figure out? I'm missing an observation, and I'm trying to kind of greedy my weight on it. Because conversely, you can imagine something like this, and it works, assuming everything else is the same, and then just change the W into that slot. So how do you do it? does this mean? This stuff is good, right? U is trivially true. X is trivially true. A we can move to the left. O we can move to the... even that's not actually true, but let's say we did that. Right? I'm trying to get a principle, not really on just this phrase, but which makes sense, but I just do the prefix thing, but for every character? That seems like a lot of work. But if it's right, then it doesn't matter if it's not. What does a swap mean? What does an operation mean? And again, you can't just do the overlap greedy thing, so you can't even do them independently. Well, maybe you can, but just keep track of it, I guess. A lot of people are getting it. Yeah, maybe not. I don't know. This isn't quite right. This is only a left of I. True. What is it about the pool of characters? $25 maybe, I'm just not getting it. But I feel like I have ideas, I just don't quite know which ones do I want to work on. Okay, I think I get it. Maybe. Maybe not. Your bag of letters to the left, your bag of... Is this a reverse trick? Maybe I have to think about if characters I cannot change. Like here. I have this, so that now I'm trying to compare to the rest, maybe? Like W. Like this W, there's no W that's in here. So then that just cannot be true then, right? It's the opposite, huh? Can I do that in 20 minutes? Don't know. So what is this W saying? This is this thing that's not in it. See this A, right? Now we look at the other side. There's an A, so it's happy. How do I calculate that quickly though? I guess that's the thing. I guess I can get this bag very quickly, but then how do I match it up with these? And also like 10 to the 5th, that's just so kind of. Is there another pre-processing of the queries? I get the idea, but I don't think that's easy to do or even doable. I feel like I need one observation. If I write brute force, how would I write brute force? I don't even know how to write a brute force. Maybe I should start with that. At this point we're at it's for free, so let's try it. Situation. Hmm. I don't even know what I'm debugging anymore. How is this? How is this out of bounds? Oh, I did it on the other side. Eh. I guess I just got lucky with small test cases. I mean, this is definitely not right, but it is a start. Wait, I put force on this one? 0255. Yeah, that's definitely wrong. I have no idea how to do this. Is this some like weird sick tree stuff that I missed? But no, I'm missing a principle. I mean, sick tree is just a data structure. Like, I don't even know what I'm doing anymore. I think I'm just one of those days I just don't get this one. Maybe a little bit out of practice. Last contest of the year. I mean, this would have been pretty okay still if I had gotten, or if I just didn't get a wrong answer on Q3, would have been like pretty okay. But 2 wrong answers on Q3 is what killed the ranking for me. That's what happens when you only have one hard problem to work on. Sometimes you're just gonna not do so well. But this isn't quite right, I know. I just don't know how to do it. I just have no idea, I think. Or like I'm missing one observation to even have an idea. Like I have some ideas about like maybe the inverse. The inverse just feels so hard to do. Because then now, okay, you're just saying that, okay, you have these, and then now you're looking at the stuff that is not in it, right? It's within this range, but this is the wildcard stuff, but let's subtract out the wildcard stuff. Some overlap code here, that's why, but this isn't quite right either, but I don't know. Well, this is just false all the way, but oh, I got the signs wrong. Still wrong though, but I don't know. I mean, definitely not gonna get in 3 minutes. I feel like I'm missing one thing. I don't know what that thing is. I mean, I feel like I made a lot of observations, but Palindrome is just a red herring, or you could transform that pretty quickly, but I think the trick is to try to figure out the cases in which it is false, but I'm not quite doing that well. I think, I mean, I think this is quite, or like, I feel like my idea is kind of right, but I think I'm not implementing it quite the clean way. And today's not even that bad if I didn't have 2 wrong answers on Q3. Just kind of silliness. And nope, I lost that case, but I have it here, I guess. But I mean, at this point, I running out of time. Yeah, I mean, at this point, I have no idea, so I'll have to. I have to get one hint, maybe, and then try to see if I can solve it. It is what it is. Only 108 people got it. I don't know, and people did a couple big wrong answers, but all right, time's up. We'll see how long it takes to refresh. Oh, I guess it refreshed. Rolling hash. I did this. Yeah, this is just reversing. So I've done this, but I don't know that I know the rolling hash. What does that mean? All right, let's do one that has it in code. I mean, rolling hash was not something that I've thought about, or though I did have the other stuff. I don't know. All right, let's actually read some code. I don't know that there's anything, whatever. Okay, so okay. Calc F and Calc C. I mean, we did this. I don't know what I and J is. Maybe it's just the left and the right. Okay, fine. All right, let's look at someone else's code. We had something like this. And this is just a helper, but what is Wes? Oh, Wes is a thing of 26 things. I still don't know that I get the idea. That's why I'm like, otherwise I would just implement it myself. And somehow you can look at stuff on page 2. What's it? All right, let's look at a Python solution. Maybe that'll be helpful. All right. That's actually kind of cute, but maybe a little bit. I mean, I wouldn't have done it this way, never, because it feels too slow. But apparently not. Maybe it's fine. I did all this. I mean, maybe not this, but maybe that's not. It's just case analysis. I kind of went that well, but I just couldn't figure it out. Huh. Alright, this looks like maybe I just couldn't figure it out today. And it would have been okay, more okay if I didn't. That cute way killed me. Where's this pipe? This one looks promising. I mean, we did this. I had some parts of this, but I don't know how I kind of take it together. B is greater than C, so that, wow, there's just a lot of case, isn't there? I guess this may be a case. How is this fast enough? I guess with Leetcode and Python, I just never know if these things are fast enough. Alright, I mean, I guess the TLDR is just kind of type it out. So let's maybe try it. Alright, fine. I mean, I had done most of it already, but yeah. So I had this stuff, and maybe I need helpers. I guess. Kind of was going down this road, but I didn't really think about it. Cheating a little bit. There's some crazy looking code, to be honest. That's why I'm like, what is going on here? I can take some cue from it, which is to say, all right. All right, I guess if there's no magic, I just have to do it out. I don't know. I don't know why I didn't. It is what it is. All right. Maybe I tried too hard to kind of make it short and tight, because I did spend a bit of time on it. But all right, let's go through the cases, right? So let's say there's no overlap, right? Then it is just okay. Yeah, if there's no overlap, then we just check. And I'll take a cue from the person. We'll just have a quick check thing. Let's see. Let's check A, B, C, D. Maybe that's fine, right? Then now. And then now, okay, and I'll put the code here. Yeah, I don't know. And then I guess there are really only two cases. No, I mean, if there's no overlap, then where's my overlap code anyway? What would it be for? I guess I knew what it is. So no overlap means if B is C. Yeah. Then that's fine, right? Then we do return. We just have to do match, right? So match of prefix L, AB. Right. And match of prefix right to left. C and D. If A is less than, or the other way, if A is greater than D, then I guess it's the same, right? It's just, yeah. Okay, right. And that's what it is. So match is just exact match. And this is the prefix. This is the match string. So I just call it S and then left, right, whatever. Should be fine. We don't use the original strings here anyway. A little bit of a shadowing, but for a helper method. But okay, then now we have the prefix. Right. Oh, I guess this is actually prefix, right? Actually, that should be pretty okay then, right? Because you just have to match the things. Yeah, okay, yeah. Actually, that doesn't even mean anything anymore. So then now what does that mean, right? That means yeah, maybe we just do a helper as well. X count is equal to count X left right, right count is equal to count right left right, and then return X is equal to YC. Yeah, okay. Prefix left right, right, and now oops. Okay. Just making sure that it runs. Okay. The crazy thing is that, to be honest, like this should have returned true, maybe. I don't know. The first one should return, at least one of them should be true, because they don't overlap. I'm usually pretty good at exhaustive problems, but I guess today I'm just feeling a bit lazy. And that is a big problem when you're coding. When you do competitive, when you don't have an energy, you don't go for grindy solutions, and this is a grindy implementation. Why am I wrong? Oh, there is overlap. That's why. Okay, fine. Oh, there's overlap in all of them. Okay, fine. All the inputs. Okay. I guess then that's fine. I thought there was at least one of them with no overlap. Okay. Now what do I do if there is overlap? Maybe I don't even know if this is really necessary, but okay. What does that mean? That means that what does this mean? I guess this part is a little bit trickier. That means okay. That means that from A to B, everything should match. Or not everything should match, but you have this delta. Is it on A or B? B basically what you're saying is, what am I saying? Because this is the part that I had trouble with actually a minute ago. Okay, so let's say there is overlap. What happens when there is overlap? That means that, okay, that means that, okay, means that from A to B on the right side, each of those has to be, it has to be at least in those. Okay, I see. I kind of had that code at some point. So then now we have to kind of figure out how to name these things. I'm really bad about it. Okay, so then now you have okay, so you have something like extra left is equal to extra of prefix of left count match with extra. So there you have xy, ab, left, right. Y is everything in Y has to be in X, and this is not B, this is, I guess, C or C minus 1 or something. Yeah, C minus 1. And basically what this we should return is okay, so then now Y count is equal to count Y left, right. Well, no, so that is true, but there's also a second right for X, right? Like Y right and X right, something like that. So then now this is B and C minus 1. Okay. And then now for J in range 26, YC sub J minus XC sub J, and then now we return YC and also I guess technically it's the other way around, but okay, fine. C or of x greater than equal to 0 for x in xc. We also record v for v. Right. If not p, then we return false, because that means that is just not possible. And then now extra on the right. P is equal to extra, pre-x left, pre-x right. Maybe the other way around. Now you have C D from the pull to get, and then C to B minus 1 is the other thing. If not P, return false. Otherwise, okay. Yeah, okay. So then now return extra left is equal to extra right, maybe. I don't know if this makes sense yet. Well, maybe I should have done this one, but still not doing anything, hey? Okay. So that means this one returned something, but it should have returned true then, right? Let's print. This part, this is the only part that I'm not super sure on. But maybe I did it. I have an issue earlier. Extra left, extra right. Overlap is from C to B. This is wrong. What this should be is from, oh, this is X left. Yeah, okay, fine. I guess there is a, yeah, okay, fine. And then now this is the left is actually B minus 1, C, D, right? Okay. The way the API is very confusing right now. Syntactically. What is not defined? Oh. That's not the overlap, friends. Oh, maybe it is. Overlap should be 0, 0. A, B, C, D. How is that possible? Oh wait, no, that is right. So then C to B, wait, yeah, C to B. So 0 to 2 is the overlap, okay. How is this the extra? A, B, C. And then only A is required. Zero to 2 is overlap. So, okay, so yeah, I guess everything is extra because everything is extra because there's no requirement on the other side. Okay, fine, because everything's on the overlap. This is a really bad case to kind of debug on. But then the other side is B minus 1. No. Is that right? It's like B plus 1 maybe. Yeah, because C, yeah, okay, fine. B plus 1D. No, this isn't quite right. Yeah, A, B. Oh, I think this is not what, I think I had this, but instead it is entirely inside one of them. Okay, fine. Let me add a test case then. What would it be? I don't know that I can get this during the contest in either way. This is just too grinding for me. But 0, 1, and then technically like 1, 2, but this 1, 2 will be 5, 6 or something. 4, 5. Okay. Still not giving me a good answer, but 1, 1. Why is this returning negative ones? This is the left. So, okay, so this is the everything in right part. And everything in right is from B plus 1. And then the full pull is C. Okay, fine. Alright, that's good. And then is this true? Just true otherwise? Maybe? I don't know if that's true. But it's untrue in the one case that it's not, so that's not great. Alright, so I guess this is an intentional force. What is this force? BC, ABC, oh no, CBA, ABC, CBA, you move this there. Oh, okay. I mean, maybe that is actually the way logic. This is just one case. And now if I'm trying to think whether it's prefix L, prefix right, and then this thing, and then you have now LR, and then maybe this is slightly cleaner because then now I can write if C A D B, right? They overlap in that, then we can just return check of RL CD AB, right? Yeah, and we already got one right answer, one more right answer. maybe even this. I don't even know if that is an actual right answer, but maybe just a little bit lucky. Okay, and then now inside, so A to C to D to B, maybe. Right. Now what? So that means that and I think there's more. I think I'm missing some stuff just because yeah, I'm definitely missing some stuff here because this is just only for this test case. For example, if I just do, even if there's no overlap, oh, my mouse sometimes goes crazy. Like if there's no overlap, I can do something like this. 8. And I think this is going to give me a wrong answer. Gave me a right answer somehow. Oh, wait, no, I think I got it. So then I do this. What is 10, 11? Yeah, I just picked a random number, so it doesn't matter. Okay, fine. Maybe that's not a good enough one. Yeah, return true when it's supposed to be false. Because I have to match all this stuff outside as well. So then now, this is a ridiculous problem. Because basically you have to match the stuff that's inside but also outside, right? So no overlap means everything that's not an overlap you have to match exactly, right? So you have to do something like and good from 0 to A, and I guess this is the part where you actually have to separate them out. This is a as they say, an annoying as hell problem. Right. This is, so then now this means that this is the case, kind of. It could be equal to, and in this case, then you want good from 0 to A. B to 1, C minus 1. Is it N or FM? Okay, fine. Otherwise, this is C. Right? So then now, this is a very silly problem. Right, and then now we need to have a good function. Left, right. inclusive. Actually, I think the way that I did is exclusive, so no, it's inclusive now. So that means that how do I want to do it? Okay, that means that total is going to right. Yeah, okay. Oops, no. Nope. Yeah, this should be four times, right? And then now we can do a bisect. I guess actually I don't really need to do that. I could just do a prefix something, right? I think I had this too. I think I had like all these ideas. I just kind of I just didn't put it together. I just also was hoping to find an easier route to do it. So if this is equal to 0, and this is good, okay, fine. All right, does this fix things? Yeah, fix this one anyway. I don't think this was ever right, so because I need this stuff. Okay, but that means that I also need to do extra stuff here as well. So we have overlaps. Okay, it overlaps on CMP, so that means there's good on 0A and good on DM-1. And this one should handle that one. Okay, fine. And now this is inside. Okay. If C and D is inside, then how do we want to do it? We have some sort of match LR. From A to C-1, everything in minus and match of D plus 1 to B. So that's definitely something. And of course, good from 0 to A minus. This is wrong because these are inclusive bounds. This is wrong after I had it anyway. And also good from B plus 1 to M-1. Okay. No, is this necessary? No. This doesn't need to be that crazy. Because if they're totally inside each other, it's actually much more straightforward. It is just essentially it is a match of XY. XY is not even a thing. Larry, you're drunk. I'm not actually drunk, but definitely feeling dumb for sure though. I think that's actually good enough. I guess technically this is an in. Otherwise, see the other inside. No, don't write it. Write it as a check of swap. And then here should assert force maybe. I'll print it out real quick. And then assert force. Give it a quick submit. I guess I don't know how long it took, but I just couldn't believe that this was I mean, I don't know. I no excuses. I think I just kind of I just didn't think it was the case. Or I really thought that there was a simpler way of doing it, but also, to be honest, I thought that 26 times Q may be a little bit too slow, but I should have YOLO'd it. But I mean, I tried, but I think I just didn't really think about case analysis as a way of doing it. Because I had all these ideas, but then I just kind of thought maybe there's a simplifying way of doing it. Yeah, I mean, I think I'm just not up to par today, which happens. Yeah, not a. I mean, actually, a lot of people end up getting it. But I feel like if I had gotten, yeah, like if I didn't get the wrong answers, this would have been kind of okay. Like, still not great, but yeah, I think there's also some tactical mistakes. Like I forgot that Q2 is equal to Q3, so I kind of spent some extra time there, but and as a result, I think I got a little bit tilted and kind of rushed Q3 because I knew how to do it, but I just kind of missed this case for one, and then I just kind of, I don't know why I put the -1 here. Even though it doesn't even make sense with symmetry, but silly mistakes. I mean, I'll go with this one. You know, in its own video, obviously, but I don't know. Just one of those days. I mean, I struggle with this one. But even knowing what to do, it took me half an hour to write. Though, I mean, I am, you know, I was more deliberate, so I don't, you know, it's fine. And maybe if I can write over D, I should actually rewrite this as check. Just swap. Maybe that would have been, I mean, it should be slightly slower even, but just less error prone. I think I need to also like just write more helper functions in general. I think that, I mean, this is fine. I already had this. I think the thing is, to be honest, some part of it is that Leetcode is messing me up, to be honest. And why I say that is because, you know, the running time is just getting in my head a little bit too much. Especially for Q4, especially for Python. Because in the back of my mind, I'm always thinking all these extra things, and the, you know, the extra function calls and, you know, and stuff like that may actually, you know, be too expensive, for example. But do I even need this extra right? Actually, I don't know. Because in theory, this gets encapsulated here. but maybe not. I am curious. So then I can just actually return this and this. Overlap at AB or at CB. Why does this work? Just want to make sure that I understand it. Everything in Y has to be an X. And then that means that the unused portion has to be overlapped, and then the overlap, it doesn't really matter what the extra stuff is. And here I can actually then now return if YC of J is greater than XC of J, we return false. Okay, I guess that makes sense. Just doing code cleanup. But yeah, and I think the natural way to write this is doing like with all these helper functions, but I think it is, like I said, Leetcode's been kind of in my head with respect to the running time and Python, and I'm doing too many premature optimizations to make it such that because I've been doing a lot of stuff inline, and that's kind of been too confusing to me, or like it's been confusing, and I've been writing kind of bad code as a result. But it's very Leetcode specific, and maybe even competitive in general specific. I don't know, but I don't use Python anywhere else. But definitely, if I was in C++, I would definitely write all these helpers. Maybe I just need to write more C++. I don't know. How is the running time on these anyway? I guess it doesn't show up here. Oh no. Is it this one? Why is it? What did I do to make it slower? Oh, because I have this extra thing. That's interesting, actually. Because this extra thing allows you to... But this is even that expensive. I guess you already do it, but this is definitely very cheap. And when I talk about premature optimization, I guess it's stuff like this, right? Where these function calls are just adding up with the overhead. Like I'm curious, if I just replace this with inline, how much faster this would be, right? What is this? A minus 1 plus 1 minus delta 0 is equal to 0. And this is just one thing, so maybe I'll just write the other one as well, just for science. is m minus 1 plus 1 minus delta b plus 1 is 0 to 0. See, like, but that's the thing, right? And it like this one minor thing about the function, you can see that it halves my time, and I think that's been just in my head lately, in that it encourages me to write bad code, which, or like I prematurely write the bad code, but then it leads to me just like getting confused all over the place as a result of just like off by ones and all these things. I don't know what to do about this, to be honest. I mean, I like, you know, for teaching, I'm going to keep it this, but that's what I mean, right? Like, I mean, this one may be an extreme one, but you know, we also call it a lot of places here, and this is just like a very simple thing, right? Like, I don't even think I can optimize it without out of here. And you could also imagine that if we had just twice the number of test cases, this would time out and this would be timing out, right? Which, you know, given Leetcode, you're not that surprised. And as a result, it just kind of makes, I don't know, it just makes me always prematurely optimizing for these things. And then now, you know, you have a cube for that. I definitely, it is definitely within my grasp to solve, but it just slows me down too much to try to prematurely optimize and write code, and also not dealing with off by ones. And even with these helpers, if you saw me doing it live, I had a lot of issues with, not a lot, but like a couple of times I'm just like, oh wait, this is an off by one, and I went back and fixed it, but before, you know, getting it wrong. But it's definitely way easier if I, you know, if I have to add one to one of these things and stuff like that. It's just way, I don't know, it's tough. I mean, all these things are, oh, this is all 26, but like, for example, if you just do like, I don't know, I mean, I could play around more optimizations, but that's what I mean by like, it's something that I struggle with problems like this because I prematurely optimize. So anyway, that's what I have for this one. Let me know what you think. This contest in general, kind of a disappointment to end the year in a couple of ways. I guess I had some ways to fix this, but I'm just curious how people did it. No, I mean, I guess they I mean, this is a little bit cleaner, but I don't know. I guess there's so many ways to make this a mess, but yeah, good job, Chi-Chi. Yeah, I don't know. Oh, this is Python. I mean, this code, it looks clean, but I mean, also had 7 wrong answers, so that's what I mean, right? And I'm not even making fun of Jan Sean. I say that as in that I respect him, and that and you know, writing it the same way that I would have when it cost him 7 wrong answers, mean that like I'm not likely to do better. And he does this, like, you know, in line for that reason, like give him more time or whatever, like probably does pretty well. Also, I probably should have this part. I guess this should have been like here and just be like left, right. But that's more for readability than anything, really. Yeah. Like that doesn't change. I don't even think it barely changes the running time. But anyway, but yeah, it's just very easy to get wrong. So I don't know. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord, and let me know what you think about today's contest. That's all I have for today. Happy New Year. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye-bye.